Welcome to The Explainer. Today we're talking about one of the most powerful and, frankly, game-changing technologies in modern warfare, the guided missile. We're going to break down the tech, take a peek into the arsenals of a global superpower and a major regional one, and try to understand how these weapons are completely rewriting the rules of conflict. You know, for most of human history, the battlefield was limited by how far you could see or how far a cannonball could fly. But the moment guided weapons arrived on the scene, everything changed. Suddenly, distance wasn't a defense anymore. It was just a number that could be crossed with incredible speed and precision. This technology fundamentally changed what it means to be a military power. So here's what we've got lined up. We'll start with the absolute basics. What exactly is a missile? Then we'll dive into the cool tech, how they fly, and what makes them so good at what they do. From there, we'll look at the real-world hardware of the United States and Iran, compare their different approaches, and then talk about what it all means for the future. Okay, let's get right into it. You hear the words missile and rocket used all the time, sometimes like they're the same thing. But there is one absolutely critical difference that puts them into two totally different leagues. And that difference is the guidance system. It's all about the brain. An unguided rocket is like a firework or a bullet. Once you launch it, its path is pretty much set by physics. A missile, though, is smart. It has an onboard brain that is constantly steering, making tiny corrections to make sure it hits a specific target, even if that target is moving. That guidance is what makes it a precision weapon. All right, so we know a missile is basically a smart rocket, but let's dig into the technology that actually makes them work, the tech that defines what they can do. And the best place to start is with the most basic question of all: how far can it go? Range is really the first big way we categorize these things. On one end, you have your short-range missiles, which are tactical weapons for a specific battlefield. And on the other extreme, you have the ICBMs, intercontinental ballistic missiles. These are the planet spanners, the strategic weapons that form the very core of nuclear deterrence. Now, this is really important. There are two completely different philosophies for how a missile gets from A to B. A ballistic missile is basically thrown. A massive rocket engine shoots it up in a huge arc, often into space, and then gravity pulls it back down onto the target at insane speeds. A cruise missile is totally different. Think of it like a small robotic jet. It has an engine that runs the whole time, and it flies super low to the ground, using the terrain to hide from radar. For a ballistic missile, understanding this three-part journey is everything if you want to stop it. The boost phase right after launch is the best time to kill it. It's big, hot, and relatively slow, but you have to be close. The mid-course phase is when it's coasting through space, giving you a bigger window to try and hit it. And the terminal phase, that's your last chance, trying to hit something screaming through the atmosphere at thousands of miles an hour. Now, the type of fuel a missile uses might sound like a minor detail, but strategically, it's a huge deal. Liquid-fueled missiles can be very powerful, but you often have to fuel them up right before launch. That process can take hours, and it's a giant flashing sign for spy satellites. Solid fuel, though, is ready to go. The fuel is already packed inside, stable and safe. It means you can launch in minutes, often from a moving truck, making it much, much harder to find and destroy. And this brings us to the new kid on the block, the one that has everyone worried: hypersonic weapons. Now, it's not just about raw speed. Ballistic missiles are already incredibly fast. The real game changer here is combining that extreme speed with the ability to maneuver. It can dodge. That combination makes it a complete nightmare for any missile defense system out there today. It shrinks warning times down to just minutes, and that has a really destabilizing effect on global security. Okay, with that tech background, let's see how this all plays out in the real world. We'll start with the United States, whose entire missile arsenal is built around one central idea: the ability to project power anywhere on the planet. The U.S. arsenal is built on the foundation of the nuclear triad. That means having nuclear weapons on land, in the air, and at sea. So a surprise attack could never take them all out. On land, you've got the Minuteman III ICBMs in heavily protected silos. At sea, the Trident II missile is launched from submarines that are almost impossible to track, guaranteeing a retaliatory strike. And for conventional attacks, the Tomahawk cruise missile, fired from ships and subs, has been the go-to weapon for decades. So how do you defend against something like that? The US doesn't bet on a single magic bullet. It uses a layered defense. Think of it like an onion. The outer layer is the Navy's Aegis system on its ships, which can take a shot at a missile while it's still in space. If that misses, the next layer is a ground-based system called DAD, which tries to hit the threat high up in the atmosphere. And if that fails, the Patriot system is the last line of defense, trying to intercept the missile in its final moments. To stay ahead of the curve, the US is developing its own hypersonic weapons. The Army's Dark Eagle is what's called a boost glide system. A rocket boosts it up to incredible speed and altitude, and then it releases a glide vehicle that can maneuver on its way to the target at over Mach 5. The whole idea is to be able to hit a critical target so quickly, the enemy doesn't even have time to react. All right, now let's shift gears and look at a very different kind of missile power. Iran's program is a perfect example of what's called asymmetric warfare. It's about using technology to level the playing field against a more conventionally powerful enemy. Developed almost entirely under sanctions, its goal is simple: deterrence. It's about making sure any potential adversary knows an attack will come at a very steep price. Iran has built up one of the largest and most diverse missile arsenals in the Middle East, and you can actually see their technology getting better over the years. Early missiles like the Shahab 3 use that cumbersome liquid fuel, but their newer weapons like the Sijil and the Fateh missiles use solid fuel. That's a huge step forward, making their forces much more mobile and quicker to launch. And Iran's program is definitely not standing still. They're actively trying to develop ways to defeat missile defenses, with systems like the Khorramshahr, which might be able to carry multiple warheads. They've also rolled out their own cruise missiles, like the Pave, giving them that low-flying attack option. And of course, the big one everyone's talking about is their claim to have a hypersonic weapon, the Fatah, which they say can maneuver at extreme speeds. So when you put these two arsenals next to each other, you see something really interesting. You're not just comparing pieces of hardware, you're comparing two totally different strategic mindsets, two different ways of using missile technology to achieve national goals. This really sums it up. The United States arsenal is all about global power projection and strategic deterrence, built on its nuclear triad and the most advanced technology money can buy. Iran's missile force is a tool of asymmetric warfare. It's a cost-effective way to hold valuable targets across the Middle East at risk, and by doing so, deter potential attack. And this chart, well, it just puts the difference in scale into perspective. It's not even in the same ballpark. A US Minuteman III can hit a target pretty much anywhere on Earth. Iran's longest-range missiles are powerful regional weapons designed to reach across the Middle East, but they just don't have that intercontinental capability. So what's the big picture here? Where is all this heading? Well, the rapid advancement and spread of missile technology is creating a new reality for warfare, a reality where response times are shrinking from hours to minutes, and even the most advanced defensive systems are being seriously put to the test. This quote from a defense expert really hits the nail on the head. You can't just solve the hypersonic problem by building a faster interceptor, because the target can dodge. It's like trying to hit a speeding, swerving bullet with another bullet. The physics of it are a nightmare, and it's forcing everyone to completely rethink how missile defense even works. And that's really the crucial takeaway. We are entering an age where the offense has a serious advantage over the defense. As these incredibly fast, precise, and hard-to-stop weapons spread to more countries, it forces everyone, from superpowers to smaller nations, to rethink the very meaning of deterrence in a world where an attack can arrive with almost no warning at all.